Okay, so objective today is to determine if a function is linear from a table. We've determined if it's linear from a graph and an equation. We're going to use these graphs here to help us determine if it's linear from a table because we'll be able to pick up on some patterns. The first thing I want to do is this linear or not? So our first table here is linear. Our second one is clearly nonlinear because it's not a straight line. Now, let's record our coordinates from left to right. This will help us identify some future patterns and create some rules. And then our last point is 2, 8. So all I did was I recorded these coordinate points into the respective tables. Okay, so now we're going to look at our first one, which is a linear function because it's a straight line. Another definition means, is a linear function will have a constant rate of change. So if it has a constant rate of change, it will have a straight line. And if it's a straight line, that means it's a constant rate of change. Your rate of change is your rise over your run, your change in y over your change in x. So what is our constant rate of change in this function? So again, this was a linear function, and now I measure my change in y over change in x by doing a little bit of simple addition. So my change in y here, if I go from 7 to 5, I'm going down 2. If I go from -3 to 0, to do that, I would have to add 3. So this -2 is my change in y, and this +3 is my change in x. So my change in y over my change in x equals -2 over 3. We want it to be equal to this every time if we're going to have a constant rate of change. So let's check the next set of points here. From 5 to 3, we would have to go down 2. From 0 to 3, we'd have to go up 3. So that gives us -2 over 3. So that's the same again, so we're good. From 3 to 1, that's -2. From 3 to 6, that's +3. Well, look at that. We knew it was linear already, and we just proved that it has a constant rate of change because for every change in y that is -2, our change in x is +3. So if all of these are the same on either side, we have a constant rate of change because we could write it as -2 over 3 every single time. Let's look at the non-example. So this is clearly nonlinear. That's definitely not a straight line. I'm going to recopy my points here from left to right. So my first one at the bottom left was -2, -8. And then working from left to right, we have -2, -1. We have 1, 1. And then we have 2, 8. So let's look at what our change in y is. To get from -8 to -1, I have to go up 7. To get from -2 to -1, I have to go up 1. So that's +1 and +7. So my change in y equals 7. My change in x equals 1. Now, that is just for the first set of coordinate points. Well, let's see if it stays the same. To go from -1 to 1, I would have to go up 2, because it'd be -1, then 0, then 2, or then 1. So that'd be up 2. To go from -1 to 1 here, I'm going up 2. So now my change in y equals 2. My change in x is also 2. So 2 over 2 simplifies to just 1, and then 7 over 1 simplifies to 7. So my change in y over change in x for my first 2 points was 7, or equal to 7. And my change in y over my change in x is equal to just 1. So are these numbers the same? No, they are not equal. That means that this is not a constant rate of change. And we didn't think it would be because we already knew it was nonlinear. Now, we want you to practice. So identify whether or not the table is representing a function. You can complete it on a piece of scratch paper and upload a picture for today's assignment. That way you can get some feedback. Remember, the first thing you want to do is you want to look at the change in y, figure out what that is, then figure out the change in x, and then you put the change in y over the change in x, and you want to see if it's the same for all of the different differences between coordinates. All right, good luck. Please reach out if you have any questions.